Approximating square roots. Recall, what is a perfect square? Complete the chart below to help you identify perfect squares. So 1 to the power of 2 is 1, 2 to the power of 2 is 4, 121. And you can use this chart throughout the lesson to kind of help you approximate square roots. Discussion. If the square root of 1 is 1, because 1 to the power of 2, 1 times 1 is 1, and the square root of 4 is 2, what can you say about the square root of 2? So the value of the square root of 2 is a number between 1 and 2. So a number between 1 and 2 means that it's not going to be a whole number. There's going to be a decimal involved. So let's investigate what that relationship might be, or what that answer might be. Investigation. Complete the table below. What do you notice about the square roots of perfect squares compared to the square roots of non-perfect squares? So a perfect square from the last lesson means that a number that is an integer, so a whole number, negative or positive, to the power of 2 will give you a perfect square. So when you take the square root of a perfect square, you're going to get an integer. Versus the square root of a non-perfect square is when you take the square root of something that's not going to end up being an integer. So let's fill out the chart below. So square root of 1 is 1. Square root of 2 is, and you can use your calculators to get this, 1.4. I notice that here I put approximately because the square root of 2, if you put it in your calculators, will be 1.4142 ... etc. Lots of other digits. So you're going to just write, round it to the nearest tenth. Okay, so the square root of 3 is 1.7, approximately. Square root of 4 is 2. The square root of 5 is, again, approximately 2.2. So let's see check if the square root is that of a perfect square or a non-perfect square. So the square root of 1, 1 to the power of 2, it's a whole number, it's an integer, it's a perfect square. Square root of 2 is not. Square root of 3 is not. 2 it is. 2.2 is not. Is a non-perfect square. 2.4 non-perfect square. 2.6 non-perfect square. 2.8 also non-perfect square, and 3 it is. So we're going to go back to the original question. So what did you notice? So the square roots of perfect squares are all whole numbers, while the square roots of non-perfect squares are decimal numbers. So I'm going to move on to the next page. How to approximate square roots of non-perfect squares. So step 1. Method 1, using a number line. Approximate the value of the square root of 23. Step 1. Determine the two perfect square numbers closest to 23. Find two perfect squares that sandwich 23. So the two perfect square numbers that 23 is sandwiched is 16 and 25. They're the closest square numbers. So the lower perfect square number is 16, and the higher perfect square number is 25, the square root of 25. Okay, and then the other square root here, so below 16 would have been 9, so 3 to the power of 2, and the one that's bigger than 25 would be the square root of 36. Step 2. Identify the two whole numbers that the square root of 23 will be between. So it is between the square root of 16 and 25, but the whole numbers would be 4, and 5. And then the square root of 36 would be 6. The square root of 9 would be 3. But we know that the square root of 23 will be somewhere between here and here. The question is where exactly or approximately. So step 3, which whole number will the square root of 23 be closer to, and explain. So it will be closer to, just by looking at the numbers, 23 to 25 is only 2 digits away. Whereas from 16 to 23, it's 7 numbers away. So it is closer to 25. So which whole number will 23 be closer to? It will be closer to 5. So 23 is 7 numbers away from 16 and 2 numbers away from 25. So if this is the square root of 16, which is 4, and the square root of 25, square root of 25 is 5, I'm going to write all the numbers in between to give you a visual. So here's the square root of 23. Then this would be the square root of 17, the square root of 23. So the difference between 16 and 23 is 7. And the difference from 16th all the way to 25 is 9. Right, so the ratio that it takes between the 16th to 25 is 7/9. So step 4, approximate the square root of 23 to the nearest tenth. So 7 divided by 9 is approximately 0.8. Hence, the square root of 23 is approximately 4.8. 4 because it can't be a 5 because it's less than 5. So it's 4 and 7/9, approximately 0.8, so 4.8. So method 2, using differences and ratios. Step 1, determine the 2 perfect square numbers closest to 23. So that is 16 and 25. Find the square root. So the square root of 16 is 4, and the square root of 25 is 5. Step 3, input the numbers in the following ratio. So just follow what it says here above. Value number to approximate, which would be 23. Subtract the lower perfect square, which in this scenario is the square root of 16, which is equal to 7. And then higher perfect square, which would be square root of 25. So 25. Subtract lower perfect square, which is 16. 25 minus 16 is 9. So 7/9. The square root of 23 is 4 and 7/9, which is approximately 4.8. If you do the square root of 23, it is 4. So I'll write that here, calculator. You will get 4.795 other digits. So round it to the nearest tenth, which the question asks. You look at the hundredth, which is a 9, therefore it's greater than 5. So you will approximate it to 4.8. if you had to round it to the nearest hundredth, you'd look at the digit 5. And it's 5 or greater, therefore, if you were to round it to the nearest hundredth, it would be 4.8 as well in the situation, because it's 795. The 9 would turn into a 0, or 4.80. Okay, so we will move on to the next method, final one. How to approximate square roots of non-perfect squares using truncating the decimal expansion. So approximate the value, same one, square root of 23 to the nearest tenth. So step 1, determine the two perfect square numbers 23 is in between. So first we will find what that could be. So 3 to the power of 2 is 9, 4 to the power of 2 is 16, 5 to the power of 2 is 25. So we know that it's somewhere between these two digits. We can conclude that the square root of 23 is greater than the square root of 16, but is smaller than the square root of 25, and that it's also closest to 5. And the square root of 16 is 4, and the square root of 25 is 5. Step 3. Square the values between the two square roots found above with one decimal place. So we knew that it was between the two numbers of 4 and 5, and is closer to 5. So now we want to look at the second number. Because it's closer to 5, we're going to start off with 4.7 instead of 4.2, because it's not closer to 4, it's closer to 5. So maybe anywhere between 4.5 and above. So 4.7 using your calculator will give you 22.09. 4.8 to the power of 2 is 23.04. 4.9 to the power of 2 is 24.01. So the number will lie between, 23 lies between 4.7 and 4.8. And it is closer to 23, the 23.04. So we can conclude that the square root of 23 is between 4.7 and 4.8, and that is closest to 4.8. Because 23.04 is closer than 22.09. Therefore, the square root of 23 is 4.8. Approximate the value of the square root of 23 to the nearest hundredth. So before it asked only to the nearest tenth, and now it's to two decimal places. So we need to find out which hundredth decimal place will be closest to the square root of 23. So 4.78 to the power of 2 is 22.8484. The square root of 4.79 to the power of 2 is 22.9441. 4.80 to the power of 2 is 22.0400. So we can conclude that the square root of 23 is greater than 4.79, but it is less than 4.8. And that it's closest to 4.8. Therefore, the square root of 23 is approximately 4.80. Explain how you would continue on to get better approximations. For example, how would you approximate the value of the square root of 23 to 3 decimal places to the nearest thousandths? Here's one way that you can answer it is that I would continue on by squaring values with 3 decimal places between 4.79 and 4.8. Then I would check which square number is closest to 23. For example, 4.794, 4.795, 4.796. to the power of 2 for each one of them. And I would see which answer solution will be the closest to 23. And that is all. Hope you enjoyed the lesson. Have a great day.